The question is, if u is equal to f of r, where r is equal to root over x square plus y square plus z square, then prove that del 2u del x square plus del 2u del y square plus del 2z del 2u del z square, which is equal to f double dash of r plus 2 upon r f dash of r. Now here this question is based on the composite function. So let us first say discuss what we have given and what we have to do over here. We have given that u is equal to f of r, means u is function of r, where r is equal to root over x square plus y square plus z square. Let us give it equation number 1. Then we have to prove that second order partial derivative of u with respect to x plus second order partial derivative of u with respect to y plus second order partial derivative of u with respect to z, which is equal to f double dash of r plus 2 upon r f dash of r. Here u is function of r and r is function of x, y and z. U is function of r and r is function of x, y, z. Then so r is composite function of x, y, z. So r is composite function of x, y, z. Hence ux, which is given as partial derivative of u with respect to x, which is equal to du dr, because u is only function of r, so we can, instead of writing del u del r, we can write down du dr into del r del x. Now what is the value of del r del x? We have to calculate its value. Du dr, it is nothing but, what is the derivative of u with respect to r? It is f dash of r and del r del x. Now we want to find out the value of del r del x. Since we have r is equal to root over x square plus y square plus z square, which implies r square equal to x square plus y square plus z square, differentiating partially with respect to x, we have derivative of r square is 2r, and again derivative of r is del r del x, which is equal to 2x. So this 2 and 2 will cancel. The value of del r del x equal to x by r. Now hence 2 becomes, now we substitute the value of del r del x in equation number 2. So ux is equal to del u del x, which is equal to f dash of r into x by r. Now, since this is the first order partial derivative of u with respect to x, but in the question we have to obtain the second order partial derivative of u with respect to x, with respect to y, and with respect to z. So let us try to again differentiating partially ux with respect to x. So we have again differentiating partially with respect to x. We have uxx are second order partial derivative of u with respect to x, which is equal to partial derivative of f dash of r into x by r with respect to x. Now here this f dash of r is function of x and x by r is also function of x. So we first apply the product rule. According to the product rule, first function f dash of r derivative of second function plus second function derivative of first function. So here we applied the product rule, derivative of u into v equal to u, first function, derivative of second function plus derivative of first function into second function. Again, here x is function of r and r is also x is function of x and r is also function of x. So if you want to find out the derivative of x by r with respect to x, we have to use the division rule. We have to use the division rule. So here Here of denominator is r, derivative of x is 1, minus numerator is x, and derivative of denominator is del r del x, whole divided by denominator square means r square, plus x by r, f days of r, derivative of f days of r is f double days of r, again derivative of r is del r del x. So now we are using this division formula. Derivative of u by v is equal to denominator v into derivative of numerator, which is u, minus u into derivative of v with respect to x, whole divided by v square. Let us try to simplify this one. F days of r into 1 is r, x into what is the value of del r del x? The value of del r del x is nothing but x by r. So we have substituted the value of del r del x as x by r upon r square plus x by r f double days of r, and again the value of del r del x is x by r. Now if we take the LCM of the first part, uxx is equal to f days of r. Now what is the LCM? It is r, so r into r is r square minus x square upon this r goes to denominator, it will become r cube, plus x by r into x by r, it will become x square upon r square into f double days of r. This is the value of uxx, or partial derivative of u with respect to x. Now similarly we are also able to get the second order partial derivative of y, of u with respect to y. So only this x and this x will be replaced by y. Nothing will be changed except these two things. Similarly, if you want to find out the partial derivative of second order partial derivative of u with respect to z, then we again this uh, x will be only replaced by z. This x will be only replaced by z. Now, according to the question, we have to adding all these three uxx plus uyy plus uzz. So let us add all these three things. So adding 3, equation number 3, 4, and 5, we have del 2u del x square plus del 2u del y square plus del 2u del z square, which is equal to f days of r into r square minus x square upon r cube plus x square upon r square into f double days of r. This is the value of del 2u del x square. Similarly, the value of del 2u del y square is f days of r into r square minus y square upon r cube plus y square upon r square into f double days of r. And the last one, what is the value of del 2u del z square? It is f days of r into r square minus z square upon r cube plus z square upon r square into f double days of r. Now, if we take the first part over here, in the first part, f days of r and upon r cube is common. So f days of r upon r cube is common. So what is remaining over here? R square minus x square plus r square minus y square plus r square minus z square. R square minus x square plus r square minus y square plus r square minus z square. In the second part, f double days of r is common. Here x square upon r square is remaining. In the second part, y square upon r square is remaining. In the third part, z square upon r square is remaining. So let us simplify again once again. F days of r cube, f days of r upon r cube. This is r square plus r square plus r square is 3r square minus x square minus y square minus z square plus f double days of r. The denominator is same in all three cases. So LCM is r square and the numerator will be simply added. So x square plus y square plus z square. But again, we know that what is the value of x square plus y square plus z square? It is nothing but r square. Similarly here, x square plus y square plus z square is again r square. So we can write down f dash of r upon r cube, 3r square minus r square plus f double dash of r square upon r square, because r square equal to x square plus y square plus z square. So this r square will cancel, and we 3r square minus r square is 2r square, and the r square 1r square will cancel. Let me write down once again, f dash of r upon r cube plus f double dash of r. This is not, it is 2 times of r square. So this r square and r square will cancel. So we have f dash of r plus f double dash of r. This is 2 times, not that, 2 times. So therefore, del to u del x square plus del to u del y square plus del to u del z square, which is equal to f double dash of r plus 2 upon r f dash of r. So this is the desired result, hence proved. Thank you.